Hi everyone, my name is Anton and I'm a developer advocate at ChanceTech. In today's video we are going to figure out how Yellowstone gRPC Geyser plugin works and how to use it. Let's go! First, let's discuss the naming. Let's start from the end. Geyser means that some time ago validator nodes have been introduced to so-called Geyser plugin. This interface allows validators to decrease the workload and stream data to external storages or services. gRPC means that this Geyser plugin interface have been developed based on gRPC protocol and the gRPC service. It means that the data is transmitted to gRPC service. Yellowstone here means that this concrete implementation has been delivered by Triton1 team within the Yellowstone project. So this is where this long name came from. Now let's talk about gRPC protocol. From user perspective, the gRPC protocol means that you have to compile client code using so-called proto compiler and then use that compiled code in your modules. Why we do that? Because gRPC by default uses protocol buffers as the interface definition language. These protocol buffers contain description of services, messages, and other data structures which are used in the gRPC protocol. The advantage of this protocol is that you can compile that specification into your desired language. In our example, we will use Python, but the list of supported languages is quite huge. Let's check the repo with Yellowstone Geyser plugin just to get more details. So, as mentioned before, for using gRPC service, we need some proto files with description of service and messages. In case of Yellowstone, we can find those files in the folder Yellowstone gRPC proto and then proto subfolder. So this is the files which we need to download to our machine and then compile a client code. Moving on to a practical example. In this example, we will listen to new tokens on pump.fun. This repo will be published as a supporting material for this video, so no worries. You can either just clone it and run it, or if you like dive into details, you can follow this tutorial step by step. So the first step for this example will be installing dependencies. We need a few models here, a gRPC, library for Python, proto compiler, modules for Solana, a module for environment variables. Then, as we discussed before, we need to download those proto files to generate client code. To keep our project clean, we'll create separate folders for proto files and for generated code. We will download both files from GitHub, from the Yellowstone repo, and then, since we use UV, we will run UV run to generate code based on downloaded proto files. After that, you will see in the generated folder 4 files. And one note here, proto compiler by default applies absolute path. Since we place our generated code into a subfolder, we need to make sure that those absolute paths are replaced with relative ones. So here you need to make sure that you have from dot import geyser pb2, and the same in the second file. So after this step, you should have downloaded proto files, generated client code, and we can proceed. Let's create our main script. Don't forget to put your credentials and endpoint to the environment variables file. First of all, we import required modules, load the environment variables, and assign our constants. Since we want to listen to new pump.fun tokens, we need to have the address of pump.fun program and to have the discriminator for create instruction. So just copy paste it into the main.py. And the next part of the script is creating Geyser connection. In the majority of cases, you will have X token authentication type, so you can either use only this one or you can copy both parts of this function. Also, important thing is to have these keep alive options, because gRPC channel can be closed or you can lose a connection without pinning a stream, which doesn't produce a lot of events. The most interesting part in this script is here, because this is the part where we define our subscription. So to listen to new tokens, we have to listen to transactions, which mention our pump program ID. We don't need failed transactions since they don't create anything, and we want to get our results as soon as possible. That's why we have commitment level processed. To understand why we have this structure or not the other one, you can go to the Geyser proto file and see this service description and messages structure. In this case, we use subscribe method, which accepts subscribe request and produces subscribe update. So we can go to subscribe request, message, right, and see that it has transactions argument. This is what we need in the request. So we use transactions, we name this subscription pump filter, and we use this account include argument of transactions. So this is the object which we need to find here, subscribe request filter transactions, and it has account include property. So here we use it, account include, and we are appending our pump.fun program. Also failed false, you can see it here, failed false. You can see other types, we will look at them in our other examples. For now, it's enough to have these three parameters to get updates on new tokens as soon as possible. If you're familiar with our pump.fun repository, then you already know how to parse those instructions. Here we have pretty much the same logic. We parse received bytes into structured data so we can read and understand it. One more thing regarding those instructions. Since we listen to all transactions which mention pump.fun program, we will receive not only new tokens, but everything, including swaps and other transactions. So when we receive a new message from our channel, we need to filter out those instructions which are not create instructions. And we can do that using the discriminator we defined at the top of our file. If you don't know how to use those discriminators to generate those discriminators, you can also check our pump.fun bot repository, or you can check the learning examples in our repository for this tutorial. One of the files will contain the example for bonding curves. That's it. If you did everything right, you will have this file with all constants defined, function for establishing connection, for creating a subscription, for decoding create instruction, and for monitoring the Solana blockchain for new tokens. Now let's run the script to check the results. uv run main.py. So the script has been launched and we can see the results in the terminal. All new tokens will be displayed here. So our Geyser listener is working fine. Let's stop it. In the learning examples of our repository, you can check other examples of how you can use different subscriptions available in the Yellowstone gRPC Geyser plugin. Let's check them now. So let's check the accounts subscription. In this example, we are listening to the updates of Radium market address. This is Repsol Ray pool, and the core part of the subscription is here. In the subscribe request, we define which filter we would like to use, name it accounts filter, and then parse the Radium market address to the account and process commitment level. Let's run this file to check how many updates we will see. In this example, we are getting account updates. So since this market is quite active, then you receive a lot of updates on that program. Okay, let's stop it. Let's check the advanced example. In the advanced example, we are listening to pump.fun program and updates to all bonding curves which are owned by that program. To do that, we using the same accounts argument, the name of the filter. Instead of account, we use owner property and filters. In the filters, we specify the filter for account data. So we want to get updates only for burden curves. That means that we will filter using burden curve discriminator. In this example, you can check how that discriminator is calculated. Let's run it too. So as you can see, huge amount of updates coming in. This is because we are subscribed to all bonding curves owned by pump.fun program. Let's stop it. Okay. Also, interesting examples for transactions. We already know how to use transactions subscription thanks to our main.py example, where we listen to new tokens. Let's check the advanced filter. In the advanced filter, we're listening to potentially arbitrage transactions. This can be achieved using account required. We specify here accounts which we want to see in each transaction. All these programs must be in the transaction in order to appear in our terminal. Let's run it. As you can see, huge amount of transactions. Probably if you want to work on it, you would add some additional filters to filter out noise from this channel. In our repository, you can find even more examples for other types of subscriptions. And one bonus is a more practical example with added parsing of instructions for Meteora Dynamic Liquidity Market Maker pool. Thank you very much for your time and attention. Feel free to submit your questions, concerns to our issue section to this repository. I hope this tutorial was useful for you, and have a nice day and see you later. Bye.